B Part 7, Tensor Algebra. Lecture 4, Numerical Example of 0 to Tensor. Now, let's set up. Let's work in R2 with the standard coordinates x1, x2, xy in the basis vector partial x, partial y. Tensor components. Define a 0 to tensor T. You see, T is the blue one, I'll mark here. You see, by the matrix Tij. These are the elements of this matrix. So I can, you see, represent this tensor here in terms of the dual space or cotangent space. 2 the x, this is the tensor product, 3 tensor product, 3 tensor product, and 5 the tensor product. This is the matrix Tij. Now, let's pick 2 vectors at a point. You see, this is similar to the advanced calculus. You just pick a value of x and find the value of f of x. X is the domain. So you pick 2 vectors is the domain. These are the components of this vector here. So this vector x is 1, 4. This is the basis vector, okay? This leads to this relation here. And also likewise, the vector y, these are the components which are given. This is the basis, so these 2 partial with respect to x and partial derivative with respect to y. Always they are the domain. They are given, must be given. So let's evaluate this map. This is a map, okay? It is the domain where the map is defined as Tij dxi tensor product dxj. And the vector x is xy partial xy and yj partial xj. This vector x and y, they belong to the vector space, you see? And these are the contravariant components, okay? And this over here belongs to the, in this case, the dual space, the cotangent space, you see? That's why you have lower indices here, Tij. So from the lecture 3, we derived the map, you see, is Tij, xi, yj. Xy, yj are the domain, the values of the domain are known. And this matrix here also is known. So you just develop, these are dummy index, I, j, j. So that dummy index, so this is a scalar, okay? You just develop here, I1, I is equal to, in this case, let's put 1, 1. 1, 1, j, j. 2, 2, j, j. Now expand, okay, on j. So this will be, j will be 1, 1 plus 2, 2, which is written right over there. It's quite clear, no problem. Now, substitute what was given. I just, these are numbers, okay? I just multiply this carefully. This is 4 minus 3 plus 24 minus 20. This leads to the codomain is equal to 5. So again, this map, you see the blue one, okay, acts on the domain, leads to a scalar which is a codomain 5. The tensor measures how the pair xy interacts with the 2 covectors encoded by the matrix. You see, that's so that these are the given data, and this to confirm that the map is, in this case, is a scalar. Okay, that's it.